Hello, hi. Welcome to the story in the brand. So this is your Siva sir. Today, in the previous class, we discussed about light reflection. Now we are going to discuss about light refraction. Light refraction. Okay, let's start. So light reflection and diffraction. So in the reflection phenomena, we discussed about. So once we will recall all the topics. So what are the topics we discussed? Okay. In the previous class, light reflection. Light is a form of energy which gives the sensation of sight. Light is a form of energy which gives the sensation of sight. The light incident on it, it reflect back. The light incident on it, it reflect back. Okay, so that is about reflection of light. The light incident on the surface. Okay, so here I am taking like this plane surface. So incident ray and the reflected ray. This is the reflected ray. The line which is perpendicular to the surface is called normal line. So incident ray, reflected ray, normal line. Angle between incident ray and normal line is called angle of incidence. Angle between reflected ray and normal line is called angle of reflection. And so you can take undeviated line, angle between reflected ray and deviated line is called angle of deviation. So I hope it is very clear, right? So now you can observe here. You can observe. So angle between incident ray and normal line is called angle of incidence. Angle between reflected ray and normal line is called angle of reflection. Okay, so angle between incident ray and normal line is called angle of incidence. Angle between reflected ray and normal line is called angle of reflection. And the angle between reflected ray and deviated line is called angle of deviation. Angle of deviation. I hope it is very clear, right? So the bouncing back of the light from the reflecting surface is called reflection of light. The bouncing back of the light from the reflecting surface is called reflection of light. Reflection of light. So the light which is incidenting on the surface is called incident ray. The light ray which is reflecting back is called reflected ray. And the light ray which is perpendicular to the plane surface is called normal line. Okay. So this is about reflection of light. Reflection of light. And so angle of deviation. So before that, loss of reflection. Incident ray, reflected ray, normal ray lies on the same plane. Angle of incident is equal to angle of reflection. Angle of incident is equal to angle of reflection. Okay. So by that, angle of deviation equal to 180 minus 2 angle of incidence, and angle of deviation equal to 180 minus 2 angle of reflection. So that is about angle of deviation. And next one, coming to the regular reflection and irregular reflection. Regular reflection takes place on smooth surface, whereas irregular reflection takes place on rough surface. Regular reflection takes place on smooth surface, whereas irregular reflection takes place on rough surface. Okay. So yes, regular reflection and irregular reflection. In regular reflection, incident light rays are parallel. So reflector light rays are also parallel to each other. The type of reflection is called regular reflection. To irregular reflection, incident light rays are parallel, but reflector light rays are not parallel to each other. So the type of reflection is called irregular reflection. Regular reflection takes place on smooth surface. Regular reflection takes place on smooth surface, whereas irregular reflection takes place on rough surface. Okay, example for regular reflection: plane surface, still water, like this we can take. This is irregular reflection. Irregular reflection you can take rough surface, and like that any wall we can observe, right? So these are the example. And coming to the next one, that is about regular reflection and irregular reflection. So coming to the image and object. So if I'm taking the plane mirror like this. Okay, so here incident ray and reflected ray. So this incident ray, we can take angle. And one more thing, we can take like this. So this so here you can observe. So in this case, if you observe, these are the incident light rays. So after reflection, those light rays are meeting at one point. So incident ray, incident ray. So incident ray, after reflection, those light rays are meeting at one point. So this is the real image. So we are extending this incident light rays. Extended incident light rays are meeting at one point. So their virtual object. Here you can observe one more thing. Here real object, because from this point light rays are coming. From this point light rays are coming. Okay, so that's why it is a real object. After reflection, if you are extended or reflector light rays, so extended reflector light rays are meeting at one point, their virtual image is forming. Okay, so this is about image and object. And coming to the plane mirror, so we can take nature of the image formed by the plane mirror. Nature of the image formed by the plane mirror. Nature of the image formed by the plane mirror. So I am taking here, this is the plane mirror. This is a plane mirror. So I am taking this object. So one light I am taking like this. After that we can take here. So it will be reflected back. Here also it will be reflected back. And here I am considering. So virtual image in plane mirror, what type of image will form image? So we are extending these light rays. These light rays will extend. The image will form here. Okay, so A, B, and A dash, B dash, A dash and B dash. Okay, so here you can observe what type of image it is. Object is real. So object is real, image is virtual. Object is virtual, image is real. Object is real, image is virtual. Object is virtual, image is real. Vice versa, it will takes place because, okay. So as I discussed in the previous case, if object is real, image will be virtual. Object is virtual, image is real. Okay, so we can take like this. And one more thing, object distance. The distance between object to mirror is called object distance. The distance between mirror to image is called image distance. The distance between object to mirror is called object distance. The distance between mirror to image is called image distance. So object distance is equal to image distance, and height of the object is equal to height of the image. Height of the object is equal to height of the image, and also it forms lateral inversion. Lateral inversion is nothing but the phenomenon of converting of right side of the object appears to be left side of the image. Left side of the object appears to be right side of the image. So this mirror image is called lateral inversion. This mirror image is called lateral inversion. Okay. and so it magnification. Okay, magnification of the plane mirror is +1. So why magnification is +1? Because height of the image by height of the object. So what type of image will form? Virtual image. So virtual image will be formed above the principal axis. So height of the image by height of the object. So same size as in the plane mirror, it will form same size of the image. So that's why height of the image by height of the object is equal to +1. So magnification is +1. So that is about magnification. And coming to the next one, spherical mirrors. There are two types of mirrors: concave mirror and convex mirror. Concave mirror and convex mirror. So spherical mirror, the mirror which in the form of curved shape is called spherical mirror. So there are two types of mirrors: concave mirror and convex mirror. Concave mirror, reflection takes place inward. Convex mirror, reflection takes place outward. So we can take ray rules and image formations, and before that terms related to spherical mirror. So terms related to center of the imaginary sphere in which mirror is a part is called center of curvature. And next one is midpoint of the mirror is called pole. So I am taking this a concave mirror. So this is a part of it. So I am considering this center point. Okay, and the midpoint of the mirror is called pole. Okay. Okay, now so here the midpoint of the mirror is called pole, and the center of the imaginary sphere in which mirror is a part. Okay. So midpoint of the mirror and the center of the imaginary sphere in which mirror is a part is called center of curvature. So center of the imaginary sphere in which mirror is a part, midpoint of the mirror. The distance between center of curvature and pole is called radius of curvature. So we can take this distance is called radius of curvature. This distance is called radius of curvature. The distance between center of curvature and pole is called radius of curvature. So width of the mirror is called width of the, so the distance between center of curvature and pole is called radius of curvature. So after reflection, all light rays will meet at one point. So you can observe after reflection, all light rays are meeting at one point, that is called focus. So that is also called principal focus. After reflection, all light rays. So after reflection, all light rays are meeting at one point on the principal axis. That is called a principal focus. The distance between a focus to pole is called focal length. Okay, so the distance between, so here the distance pole, focus to pole is called focal length. Focus to pole is called focal length. And I hope it is very clear. Just check once. Okay. So once again, the center of the imaginary sphere in which mirror is a part. So the center of the imaginary sphere in which mirror is a part is called center of curvature. The midpoint of the mirror is called pole. The distance between center of curvature and pole is called radius of curvature. So after reflection, all light rays are meeting at one point on the principal axis, that is called focus. The distance between focus to pole is called focal length, and the distance between center of curvature and pole is called radius of curvature. Okay. So I hope it is very clear. And the width of the mirror is called aperture. Actually, here I took the concave mirror. So this is a concave mirror. So I hope it is very clear. Concave mirror. Then we can take the width of the mirror only where reflecting taking place. The reflecting surface is called aperture. The reflecting surface is called aperture. I hope it is very clear. So that's enough. That's enough. This is about terms related to spherical mirror. Terms related to spherical mirror. Next one are ray rules and image formations, already explained. So just recalling. So ray rules and image formations and sign conventions. Coming to sign conventions. So I'll sing one song for sign conventions. Just new Cartesian sign convention, new Cartesian Sign convention, all distance measure from the pole. Distance are positive along the instant trace. Distance are negative opposite to instant trace. Distance are positive above the principal axis. Distance are negative below the principal axis. New Cartesian, sign convention, new Cartesian, sign convention, all distance measure from the pole. Distance positive along the instant trace. Distance negative opposite to instant trace. Distance positive above the principal axis. Distance negative below the principal axis. New Cartesian, sign convention, new Cartesian. So like this. So I hope it is very clear. Okay. So next. So now we are going to discuss about refraction chapter, refraction topic. Okay. Refraction topic. So we'll discuss. So refraction. So what is a refraction? Refraction is nothing but when light ray is passing from one medium to another medium, when, so here you can take refraction. So refraction is nothing but, so I'm taking this plane mirror. Okay, actually this is a rarer medium and denser medium. Okay, rarer medium means speed of light is more in the medium, and denser medium means speed of light is less in the medium. So example for rarer is air. Example for denser is we can take water. Example for rarer medium is air. Example for denser medium is water. Okay. So if the light ray is passing from rarer, interference of the two media, the light ray will bend. Okay. So at this point, so I'm taking here, I'm considering like this. So this is incident ray. This is the incident ray. Incident ray. So here this is the normal line, and this one is the refracted ray. Okay. So this is the incident ray, refracted ray. This is a refracted ray. Okay. So the angle between incident ray and normal line is called angle of incidence. Angle between refracted ray and normal line is called angle of refraction. So we can take angle of refraction. Okay. So the light ray is moving from rarer medium to denser medium. At the interference of the two media, it will bend. Okay, so at the point of interference, at this point the light ray changes its direction. So incident ray, refracted ray. So at the point of interference, the light ray will bend. Okay, so this phenomena is called refraction of light. So the phenomena of bending of light or changing the path of the light at the interference of the two media is called refraction of light. Is called refraction of light. I hope it is very clear. So at this point, the light ray changes its direction. Okay. So that's enough. The angle between incident ray and normal line is angle of incidence. Angle between refracted ray and normal line is called angle of refraction. Okay. So this is about refraction of light. Refraction of light. Right? Yes. Now, laws of refraction. So what are the laws of refraction? Laws of refraction are nothing but, so point number one, you can take point number one. Incident loss of refraction. Loss of refraction. Loss of refraction. So here you can observe. So incident ray refracted ray normal line. Incident ray refracted ray normal line lies on the same plane. So second one is, so the ratio of sine of angle of incidence to sine of angle of refraction equal to constant. So that we can denote with the letter n. Okay. So the ratio of sine of angle of incidence to sine of angle of equal to constant. Okay. So I hope it is very clear. So sin I by sin r equal to n. Sin I by sin r equal to n. So refraction of light. Refraction of light. So the bending of the light, the interference of the two media is called refraction. And so the angle between incident ray and normal line. Incident ray and normal line is called angle of incident. Angle between refracted and normal line is called angle of refraction. So coming to loss of refraction. Coming to loss of refraction. Loss of refraction. So incident ray refracted a normal line. Okay, lies on the same plane. And ratio sine of angle of incidence to sine of angle of refraction equal to constant. Okay, so this is about loss of refraction. Right? Now, so we'll discuss. So if the light ray is passing from rarer to denser, it bends towards the normal line. So you can observe. So I am considering here this is a medium, rarer medium and denser medium. If the light ray is passing from rarer to denser, if the light ray is passing from rarer to denser, it bends towards the normal line. It bends towards the normal line. So angle between incident ray and normal line is called angle of incident. Angle between refracted and normal line is called angle of. The light ray is passing from rarer to denser. If it is passing from denser to rarer, what happens? So I am taking like this. So if it is passing from denser to rarer, so this is a rarer medium, denser medium. So it moves away from the normal line. This is the angle of incidence and angle of refraction. Okay. So here you can observe in this case, case 1, I am taking case 1 and this is a case 2. In case 1, angle of incidence is greater than the angle of refraction. In this case, angle of refraction is greater than the angle of incidence. Why? So if you observe carefully here, so what happened? So here light ray is moving from rarer to denser. Means speed of light is changing. Speed of light is decreasing in denser medium. So that is what? That is the reason light ray is bending towards the normal line. So in this case, light ray is moving away from the normal line because light ray is moving from denser to rarer. Denser to rarer. So speed is increasing. Here speed is decreasing. Here speed is increasing. That's why angle of incidence is greater than the angle of refraction. In this case, angle of refraction is greater than the angle of incidence. Angle of refraction is greater than the angle of incidence. Okay, na? So that's the difference. So this is about refraction, loss of refraction and condition. So these are the conditions. I hope it is very clear. Okay. Right. Now, so we will discuss about prism, glass prism. So let's start. Let's start. Let's start. Let's start. So coming to glass lab. Okay, so now you can observe this is the incident ray, emergent ray. Incident ray, emergent ray, incident ray, emergent ray. So here, incident, emergent ray. What is this one? Incident ray and emergent ray. So the angle between incident ray and normal line is called angle of incidence. Angle between refracted ray normal line is called angle of refraction. Angle between emergent ray and normal line is called angle of emergence. Angle of emergence. So here you can observe in this case. So this is a rarer medium, denser medium. Again denser to rarer. Denser to rarer, right? So if you observe carefully, if the light ray is passing from rarer to denser, it bends towards the normal line. If it is passing from denser to rarer, it moves away from the normal line. Understood? So if the light ray is passing from rarer to denser, it bends towards the normal line. If it is passing from denser to rarer, it moves away from the normal line. Right? Yes. So that is about here. What is the difference? Here you can observe this is the incident ray. Extended incident ray is parallel to. So actually this is the initial path of the incident ray that is parallel to the emergent ray. Parallel to the emergent ray. Okay. So the distance between initial direction of the incident ray to emergent ray is called lateral shift. Is called lateral shift. Lateral shift. The distance between emergent ray and extended incident ray is called lateral shift. Coming to the vertical shift. So here I am taking the glass. So suppose if you take the beaker or glass, and so I here a person is there. Okay. So I place the coin at the bottom of the beaker. Okay. From this position, he can't able to see the coin. Okay. So from this position, he can't able to see the coin. This is the coin. Okay. So person. So when you pour water, after pouring water into the beaker or glass, then the coin position will be rising. If you are pouring water continuously, it will be rising. So after pouring water, the coin position will rises up. Okay. So here it will rises until here it rises. Then we can able to see. So we can able to see the coin. So the distance between vertical position to apparent position of the coin is called. Okay. So the distance between upper. So actually this actual position of the coin. This apparent position of the coin. Apparent position or apparent position. Okay. So this is actual position and this is apparent position. So the vertical distance between actual position to apparent position of the coin is called vertical shift. Vertical shift. So the distance between actual position to apparent position of the coin is called vertical shift. I hope it is very clear. So what is our lateral shift? The distance between emergent ray to extended incident ray or initial direction of the incident ray. That is called lateral shift. Coming to the vertical shift, the distance between actual position to apparent position of the coin is called vertical shift. Okay? Yes. Clear. Now, so I am placing one more. If I place the pencil, so I am placing the pencil like this. Like this, if I place, it appears to be bent. Okay. So at the point of interference of the air and water, this is the air and this one is the water. So at this position, the pencil appears to be bent. Okay. So at this position, the pencil appears to be bent here because of the refraction. Because of the refraction phenomena. Okay. So at the point of interference between air and water, at this position, the pencil appears to be bent. And if you place the coin, lemon inside of the water, so if you are taking the beaker, so you can place the lemon, it appears to be bigger because of refraction. It appears bigger. Lemon, so you can take this as a lemon. Okay now. So this is a glass slab, incident ray, refracted ray and emergent ray. Incident ray, refracted ray and emergent ray. Incident ray, refracted ray and emergent ray. Angle between incident ray and normal line is called angle of incident. Angle between refracted ray and normal line is called angle of refraction. Angle between emergent ray and initial direction of the incident ray is called angle of emergence. The distance between angle between emergent ray and normal line is called angle of emergence. The distance between emergent ray and initial direction of the incident ray is called lateral shift. Okay. So here you can observe apparent position. What is the apparent position? The distance between actual position to apparent position of the coin. So actually the coin is here before pouring water. So beaker, coin is placed at the bottom of the beaker. The person is standing here. Once he look at the coin, so through the glass, so he can't able to see the coin. After pouring water, he can able to see the coin due to refraction. So the distance between actual position to apparent position of the coin is called vertical shift. So even you can take the pencil. Pencil is placed in the water. So at the interference between air and water, say at this position, at this point, pencil appears to be bent because refraction. And in this case, you can see if you take the beaker, fill the water inside of the beaker and place the lemon, it appears bigger because of refraction. Okay, so I hope it is very clear. So this is about refraction. Okay. Now, so we'll discuss about critical angle and total internal reflection. Let's see. Okay, so now rarer medium and denser medium. So this is the source. Light ray is coming from denser to rarer. Generally, what happens if the light ray is moving from rarer to denser? It bends, it moves away from the normal line. Moves away from the normal line. So this is the angle of incidence and angle of refraction. So same light ray, if it is moving from, so denser to rarer at the point of interference. Normally, if you are taking like this surface, if you are taking like this, okay, you keep on sending the light ray. You keep on sending the light ray. So at the point of interference, at the point like this. So at the point of interference, at this point, the light ray gazes along the surface. The light ray passes along the surface. Okay, or it makes 90 degrees with the normal line. 90 degrees with the normal line. So this is called critical angle. 90 degrees. Okay. So this angle between incident, this angle of incidence. Okay, so this light ray makes, refracted ray makes 90 degrees with the normal line. Then that is called critical angle. The angle at which the refracted ray passes or gauges in the rarer medium or makes 90 degrees with the normal line is called critical angle. Okay, and so if the same light ray, so you can take light ray like here. I am taking light ray like this. Okay, so at certain angle of incidence, the refract, so this is the angle of incidence. So it makes more than 90 degrees. So here is 90 degrees, then theta. Okay. So it makes more than 90 degrees, then it will be reflected back into the same medium. Okay. So this phenomena is called total internal reflection. Total internal reflection. Okay. Incident ray, reflected ray. So angle between normal line, this normal line and surface 90 degrees, and so this theta is extra, so more than 90 degrees. More than 90 degrees. Reflected ray makes more than 90 degrees. So actually refracted ray makes more than 90 degrees. Then it will be reflected into the same medium. This phenomenon is called total internal reflection. Total internal reflection. Observe carefully here. So from starting onwards, you can see here incident ray. So light ray is coming from incident ray. Light ray is coming from denser medium. Light ray is coming from denser medium. It is incidenting on the surface. So here the angle between incident ray and normal is called angle of incidence. Here reflected ray, refracted ray is moving away from the normal line. Refracted ray moving away from the normal line. The angle between refracted and normal is called angle of refraction. And see, refracted ray passes or gauges or moves along the surface. So this is the interference. So between rarer medium and denser medium. So this refracted ray passes along the surface, along the interference, are making 90 degrees with the normal line. So then this angle is called critical angle. So this is the source. Light ray is coming from here. So here you can observe after reflection, so it is making more than 90 degrees. So refracted ray making more than 90 degrees, then it will be reflected back into the same medium, into the denser medium, incident ray and reflected ray. So both are in same medium, denser medium. Okay. So it is making more than 90 degrees. This phenomenon is called total internal reflection. That phenomenon is called total internal reflection. The angle at which refracted ray makes 90 degrees with the normal line is called critical angle. So the refracted ray makes more than critical angle, then it will be reflected back into the same medium. Okay, so this phenomenon is called total internal reflection. Total internal reflection. So now we will discuss about one more. Now, so we can going with one more point, that is refractive index. Refractive index. Refractive index. Refractive index. So what is the refractive index? Refractive index is nothing but, so before I explained about laws of refraction. So I explained laws of refraction in that so incident ray, refracted ray, normal line lies on the same plane. Okay, lies on the same plane. And one more point, what is that? Sine of angle of incident to sine of angle of refraction equal to constant. That is nothing but refractive index. So here there are two types of refractive index. One is absolute refractive index, absolute refractive index, absolute refractive index, absolute refractive index, and the second one is relative refractive index, relative refractive index, relative refractive index, relative refractive index. So coming to absolute refractive index, coming to absolute refractive index, so speed of light in vacuum by speed of light in medium. So n equal to c by b, n equal to c by b. Speed of light in vacuum by speed of light in medium, that is called absolute refractive index. Absolute refractive index. Okay, so comparing with the refractive index of air or vacuum with respect to another medium. So sorry, well, speed of light in vacuum is speed of light in medium. So this is absolute, right? So comparing with the speed of light in vacuum by speed of light in any medium. So this is speed of light in vacuum or air. So only with that you are comparing with the different medium, remaining medium. Then that is called absolute refractive index. Absolute refractive index. Coming to relative refractive index. So I am taking this a medium 1 and medium 2 and in medium air or water and glass, water and glass. Okay, actually air we should not take. So any medium we can take other than air. Okay, 3, 4, 5, 6 or anything we can take, right? Then we can consider absolute relative refractive index. Relative refractive index. Relative refractive index. So what is the relative refractive index? Okay, so relative refractive index if you take, so n2 1, n2 by n1, n2 by n1. So whatever medium comes first, that you have to write starting. Then remaining medium. So n2 1, n2 1, n2 1. So this also can be written in this manner, n2 1, n2 by n1. Like this also we can take. Okay. So here the point is, whichever the medium comes first, that medium you have to write in the numerator, next one in the denominator. So I am taking the medium 2 with respect to 1. Medium 2 with respect to 1. Same. So these two we can write. So anything they can give. Any one they can give. Okay, now make sure that you are understanding the concept. Concept is very important. N2 1. N2 by N1. N2 1. N2 by N1. Okay, so this is a relative refractive index. Coming to absolute refractive index. So N equal to C by B. So that is absolute refractive index. This is a relative refractive index. I hope it is very clear. So that is about refractive index concept. Refractive index concept. Okay. So very important, very essential topic, very sensitive topic. So be careful, be aware of it. So very sensitive topic. Definitely one question will come based on this concept. So expected question. So 2 marks question. So make sure that you are practicing this concept. Okay. So just check once. Absolute means n equal to c by v. Relative refractive index is nothing but n21, n2 by n1 or n21. So chalo, let's start the next concept, that is about lenses. La 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 la. Na 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 Okay, done. So next one, what is that? What we are going to discuss? Lenses. Spherical lens. Now we are discussing about completely convex lens. Convex lens is also known as converging lens, whereas concave lens is also known as diverging lens. Convex lens is also known as converging lens, whereas concave lens is also known as diverging lens. What is a concave lens? Concave lens, so here you can take, when light rays are on it, so those light rays will be converged and meet at a point. Okay. So this is a convex lens. So convex lens is also known as converging lens. Optic center. So this side will be taken 1. So this is F1, 2F1 or C1, and this side we can consider F2 and 2F2 and also C2. Convex lens. Coming to concave lens. Concave lens. Optic center F1, 2F1, C1. Here F2, 2F2 or C2. Okay. So this is a convex lens and this one is concave lens. Concave lens. Convex lens and concave lens. Convex lens is also known as converging lens. Converging lens. Converging lens. And concave lens is also known as diverging lens. Because, sir, why you are calling concave lens is a converging lens and why you are calling concave lens is a diverging lens? Because whenever light rays are incidenting on it, so it will be converged. Light rays will be converged. So here, like this. But whereas here, after incidenting, the light rays will be diverged. So like here, like this. So converging lens, concave lens is also known as converging lens, whereas concave lens is also known as diverging lens, right? So ray rules and image formations we'll discuss. Ray rules and image formations. So convex lens, optic center, f1, f2, 2f2. So ray rule 1. So if the light ray is coming from infinity after refraction, it passes through focus. So if the light ray is passing through, so f1, 2f1, f2, 2f2. Light ray is passing through focus. After refraction, it will become. So incident ray, refracted ray. Third one, optic center, f1, 2f1, f2, 2f2. So light ray is passing through optic center. You can observe here in these three cases, light ray is coming from infinity. After refraction, it passes through focus. Light ray is passing through focus. After refraction, become parallel to the principal axis. Light ray is passing through optic center. Okay, it won't be deviated. So again, it won't get back. So deviate like that. So here, first, second, third, three cases. And coming to the next one, concave lens. Optic center, f1, 2f1, f2, 2f2. So ray rule 1, light ray is coming from infinity after refraction. So it passes through focus. Light ray is coming from infinity after refraction. So here light ray is coming from infinity after refraction, passing through focus. Here light ray is coming passing through focus after refraction, moving to infinity. Parallel to principal axis, light ray is passing through optic center, no deviation. So in this case, light ray is coming parallel to the principal axis after refraction, passing through focus. Light ray is passing through focus after refraction, moving towards infinity. Light rays passing through optic center, no deviation takes place. Convex lens and concave lens, convex lens and a concave lens. So now we are going to discuss about image formations. So image formations. So image formations. Hi, how are you? So I'm fine, doing good. So if you like the content, do like, share and subscribe to Student the Brand. Share to your friends, ask your friends to join to the class. Okay, so just go and watch my videos which are there in the channel. So related to physics, so related to concepts, whatever I'm explaining on the board, same topics. Those are continuous topics are there. Just you can check once. If you like the channel, if you like the content, if you like the explanation, do like, share and subscribe to Student the Brand. Hey, hi, how are you? So I'm doing good. Okay, chalo. So I will explain about so image formations by convex lens. Image formations by convex lens. Convex lens, convex lens, convex lens, convex lens. Na 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 na. Optic center F1, 2F1, F2, 2F2. Okay. So so light rays object is at infinity. So how many light rays I'm taking? One light ray I'm taking like this. So another light ray I'm taking. So after refraction, those light rays are meeting at one point here. Okay. So object is at infinity. Object is at infinity. Image is forming at f2. Nature of the image is real and inverted. Size of the image is highly diminished. So point size image is forming at f2. Coming to the next one. Na, 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 na. La 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 na 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 so now in this case, object is placed beyond 2f1 or so we can take c1 also. Here I am taking like this. One light I am taking after refraction, it passes through focus. Focus, 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 focus. So thank you so much. So please do like, share, and subscribe to Student the Brand. Share to your friends. So ask them to see the class, attend to the class. So kindly support to my channel. So please do like, share, and subscribe to Student the Brand. Please share to your friends. So ask them to watch the videos. So there are many physics related content is available in my channel. Abundant resource of physics. You can check once if you like it. If you really appreciate my work, please do like, share, and subscribe to Student the Brand. Thank you so much. Share to your friends as much as possible. I'll teach 12th also. So currently going on. So 12th topics also it's going on. 10th, 11th, 12th like that continuously I'm taking classes. So on schedule. So definitely. So please refer to your friends. Refer to your friends. Ask your friends to join to the class. So ask, see 12th related to 12th grade. So videos are there in my channel. Once check once. Okay, so you can check. Yeah, related to ray optics, first one check the videos. Check the videos related to ray optics topics are there. So see in the playlist. If you once go through that once go through the topic, 10th light reflection and diffraction related to that only little bit content is added. Definitely I will teach ray optics also. So first, please do like, share, and subscribe to Student the Brand. Support my channel. So already videos are there. Already videos are there. If you support me, if you like the channel, if you subscribe my channel, definitely I'll get boosting. Okay. So by that I can create more videos. I can create more lectures like this. Okay, so thank you so much for your support. So those who subscribed the channel and those who like the channel, those who shared the channel, so thank you so much. So I can say thanks. So thank you so much. Definitely I'll work out my level best to give the best way of concept explanation, so presentation. So from my end, thank you so much. Please do support like this and share as much as possible to your friends. Ask your friends to join. Those are there, especially 10th classes. Frequently I'm taking classes, remaining classes, so I'm taking and uploading. So it's the and schedule basis. So do like and related to 11th and 12th there are many videos are there like definitions, like a shorts. Just to go and check once. If you like it, you can share to your friends. Completely it's related to physics, entire channel. So fully dedicated towards physics. So thank you so much. Please do like, share, and subscribe to Student the Brand. Okay. More than that. So it. Okay, so object is placed beyond 2F1. Image is placed. Image is formed between F2 and 2F2. So nature object is placed between beyond beyond 2F1. Image is forming. Image is forming between F2 and 2F2. F2 and 2F2. Nature of the image is real and inverted. Nature of the image is real and inverted. Real and inverted, and the size of the image is diminished. So if you encourage my work, if you support my work, definitely I'll come with more creative ideas and more concept explanation. So thank you so much. So that's enough. So this is the second one. Coming to the next one. Object of F1, 2F1, F2, 2F2. Object is placed at 2F1. Object is placed at 2F1. So image is forming at 2F2. So image is forming at 2f2. f2 and 2f2. So one light I am taking like this. So it passes through focus. Another light ray is passing through optic center. So the image will form between, the image is formed at 2f2. Object is placed at 2f1. Image is forming at 2f2. Nature of the image is real and inverted. Size of the image is same size. Same size. Come. This is about three image formations. So first one, object is placed at infinity. Image is forming at f2. So nature of the image is real and inverted and highly diminished. Here object is placed beyond f1. Image is formed between f2 and f2. Nature of the image is real and inverted and diminished. Here object is placed at f1. Image will form at f2. Nature of the image is real and inverted and same size. Okay, so this about convex lens image formations. Now, so only 3 cases are over. Still 3 more cases are. Explain those cases also. So object is placed between 2f1 and f2. So it is about convex lens. Convex lens. I am discussing about convex lens. So fourth one. So convex lens. Optic center f1, 2f1, f2, 2f2. Object is placed between f1 and 2f1. f1 and 2f1 object is placed here. So how many light rays are required to form the image of the object? Minimum 2 light rays are required to form the image of the object. So one light ray I am taking like this. After refraction, it passes through focus. So another light ray is passing through optic center. So those light rays will meet beyond. So here at this point. Okay. So object is placed. Object is placed between f1 and 2f1. Image is forming. Image is formed beyond 2f2. Image is formed beyond f2. Image is formed beyond 2f2. Nature of the image is real and inverted. Real and inverted. Size of the image is enlarged. Compared to object, image size is increased. Compared to the object, image size is increased. So coming to the fifth one. So I am taking here. So optic center f1, 2f1, f2, 2f2. So object is placed at f1. Object is placed at f1. One light ray I am taking like this. So after that passes through focus. Another light ray is passing through optic center. Okay. Object is placed at f1. Image is formed at infinity. Object is placed at f1. Image is formed at infinity. Nature of the image is real and inverted. And the size of the image is highly enlarged. So that is about fifth case. Coming to sixth case. Optic center f1, 2f1, f2, 2f2. Object is placed between f1 and O. Object is placed between F1 and O. One light ray I am taking like this, it passes through focus. Another light ray is passing through optic center. So if we are extending these light rays, the image will form the same side of the object. Object is placed between F1 and O. Image is forming same side of the object. Same side of the object. So nature of the image is virtual erect. Virtual erect, and size of the image is enlarged. So this one is very, very important. Size of the image. So this is the sixth case. So you can check once. These are the three image formations. So object is placed. So in this case you can observe object is placed between 2F1 and F1. Image is formed beyond 2F2. Nature of the image is real and inverted, and size of the image is enlarged. So in this case, object is placed at F1. Image is formed at infinity. Nature of the image is real and inverted, and size of the image is highly enlarged. Coming to here, object is placed between F1 and O. Image is formed beyond same side of the object. Nature of the image is virtual erect and enlarged. Okay, so in this case only we'll get virtual erect and enlarged. So very, very important. Okay, virtual erect and enlarged image will form. So make sure that you are practicing this case. Okay, so this is about convex lens. So coming to concave lens only two cases are there. Concave lens only two cases. Concave lens only two cases we'll see. So here I am considering like this. Okay. So optic center F1, 2F1, F2, 2F2. Okay. So object is at infinity. So image is forming at F1. Okay, object is placed at infinity. Image is forming at F1. Nature of the image is virtual erect and highly diminished. Because image is formed at F1. So next one. So only two cases are there. Very simple, very easy. So here I am taking optic center F1, 2F1, F2, 2F2. Okay. So object is placed anywhere between optic center and infinity. How many light rays are required to form the image of the object? Minimum 2 light rays. So one light ray I am taking like this, another light ray I am taking like this. Okay, so if you are extending like this, the image will form between F1 and O. The image will form between F1 and O. So object is placed between infinity and optic center. Infinity and optic center. Image will form between F1 and O. F1 and O. Nature of the image is virtual, erect, and diminished. So in these two cases, you can observe very important conditions. If the object is placed, okay, so in front of the lens, so always we will get virtual, erect, and diminished image in concave lens only. In concave lens only, if the object is placed in front of the lens, it's virtual, erect, and diminished. Virtual, erect, and diminished. So in convex lens, it will be different according to the position. Yeah, this is a concave lens. Concave lens. This is concave lens. Only concave lens. Okay, so in concave lens, yeah, this is concave lens. Okay, so in concave lens, only two cases. So very, very important. Okay, very, very important. So only two cases, always virtual, erect, and diminished image will form. Virtual, erect, and diminished image. Okay, so practice this one, concave lens. So do like, share, and subscribe to Student the Brand. So share to our friends. So do support my channel. If you like the content, if you like the explanation, so share as much as possible to your friends. If you support and encourage channel, definitely I'll come with a more creative ideas and a more creative concept explanation. Okay, so definitely I'll do it. So this is about convex lens image formations and concave lens image formations. Okay, so now we will discuss about so if you have any doubts, so my phone number already given in the channels. Check once. So this is the phone number for any doubts related to any subject. Doubts. Okay. For any queries related to physics and classes, you can contact to this number. Already given. So in the classes, just check once. Okay. Right. Okay, so next, power of lens. Power of lens is nothing but reciprocal of focal length. Power of lens is nothing but reciprocal of focal length is called power of lens. Okay, reciprocal of focal length. So P equal to the degree of converging or diverging of lens achieved is known as power of lens. So do like, share, and subscribe to Student the Brand. Share to your friends, ask your friends to join to the class and share as much as possible. Okay. So P equal to 1 by F, the rate of doing work. Sorry. The degree of converging or diverging of lens achieved is known as power of lens. Or simply we can say reciprocal of focal length. So for convex lens, For convex lens, power of lens is positive. For concave lens, power of lens is negative. For convex lens, power of lens is positive. For concave lens, power of lens is negative. Okay, and so SI unit of power of lens is diopter. Unit is 1 by m, or we can also take meter power minus 1, because so focal length is nothing but distance, meters. So that's why 1 by m equal to m power minus 1. So that's sorry for it. Okay, so just check once. This is about reciprocal of focal length. So P equal to 1 by f, that is 1 by m power minus 1. Power of lens is positive for convex lens. Power of lens is negative for concave lens. Okay, done. So we'll go to the next one. So maximum we discussed. So about refraction. So lens. So power of lens and sign convention. Anyway, we are following for mirrors only. That's enough. Till now, what we discussed related to mirrors. So reflection of light, regular reflection, irregular reflection. Okay, regular reflection and irregular reflection related to that. So we discussed. And next one, image and object, real image and virtual image, like that we discussed. Next one, nature of the image formed by the plane mirror. Nature of the image formed by the plane mirror we discussed. So after that, we discussed about concave mirror and convex mirror. Concave mirror is also known as converging mirror. Convex mirror is also known as diverging mirror. So ray rules and image formations are terms related to spherical mirror. The line joining of center curvature and pole is called principal axis. The distance between center curvature and pole is called radius of curvature. After reflection, all light rays will meet at one point on the principal axis called focus. That is called principal focus. The distance between focus to pole is called focal length, and width of the mirror is called aperture. So this all we discussed. Next one, ray rules, image formations. After that, sign conventions. The along the distance, along incident rays, along the incident rays direction, all are positive. Opposite to incident rays negative. Above the principal axis, it is positive. Below the principal axis, it is negative. Sign conventions. 1 by f equal to 1 by v plus 1 by u. That is a mirror formula. So magnification is height of the image by height of the object. That is minus v by u. So that is mirrors. And coming to lens, refraction, absolute refractive index, relative refractive index, and critical angle, total internal reflection. So all those points we discussed. And coming to the next one, refractive index, absolute refractive index, relative refractive index, and glass lab. In that lateral displacement, lateral displacement, and vertical shift, lateral shift also we can say, those points. And after that, we discussed about a convex lens, ray rules and image formations. Convex lens, ray rules and image formations. After that, now we discussed about power of lens, reciprocal of focal length. Okay, so under lens formula, 1 by f equal to 1 by v minus 1 by u. There's a lens formula, and magnification is height of the image by height of the object, v by u. Okay, so degree of power of lens, the reciprocal of focal length, and degree of converging or diverging of lens achieved is known as the power of lens. So that's enough. So these are related to light reflection and diffraction. And coming to electricity and magnetic effects of electric current, everything we will discuss in the next class. So do like, share, and subscribe to Student the Brand. Please support my channel, encourage the channel. So support the explanation. Definitely, I'll do my level best, take the classes. Thank you so much.